Today we are going to learn about spectrum. There are two emission spectra. So the first one is continuous spectra. Second one is line spectra. If you observe this diagram, right, this one is continuous spectra, and then the emission of sodium, hydrogen, and mercury atom is line spectrum. What is the difference between line spectrum and continuous spectrum? Line spectrum consists radiation or a series of discrete line with specific wavelength. It had discrete or definite line. If you look at the sodium, hydrogen, and mercury spectra, so you can check 1 and then 2. So this is a discrete line or definite line. Each line separated by a blank area. The black color one is the blank area. So the example is emission spectrum of an atom. Okay, for continuous spectrum, the radiation consists of all wavelengths in the visible region. There is no discrete or definite line that separate the color. So each of the color merge into the next without a break. For example, rainbow, sunlight, and light from bulb. Okay, we check for the continuous spectrum. Consists of all series of electron magnetic wavelength, unbroken sequence of frequency, produced by incandescent solid, liquid, and compressed gas. We can observe the continuous spectrum from the visible series, means Balmer series. So Balmer series under visible. How the formation of continuous spectrum? Okay, first of all, there is a source of light. So the white light from the incandescent lamp is passed through a slit, then a springs. It will separate into a spectrum. The white light spread out into a rainbow of color, produce a continuous spectrum. So this continuous spectrum is continuous in that all wavelengths are present and each color merge into the next without a. Next point is line spectrum. Another name for line spectrum is atomic spectrum. Consists radiation of discrete line, like this discrete line, with specific wavelength or frequency. Produced by excited atom or ion as the electron fall back to a lower energy level. Composed of only a few wavelengths, giving a series of discrete lines. So few wavelengths giving discrete line separated by a blank area. White area, the white color here. So for the formation of line spectrum, right, we try to using an example of gases hydrogen. It will dissociate into hydrogen atom and excited by an electric discharge. So here exciting by electric discharge tube. Then the emitted light passed through a slit and a prince, which the light disperses into individual wavelength. So the light does not create continuous spectrum, but it creates line spectrum. You see, 1 line, 2 line, 3 lines. So this is the line. So for the formation of line spectrum, right, first atom must absorb energy, cause the electron to move from a lower energy state to a higher energy state. But at the higher energy state, it is very unstable, so it will fall back to a lower energy. While it fall back to a lower energy, it will release energy in terms of photon or in the form of this. Fall back to a lower energy level, so will release energy in the form of light, or we call it as photon. So this one is Lyman series because all the electron fall back to the n equal to 1. So Lyman series, we check. Here is the first line for the line spectrum. So means from this line is produced from n equal to 2 to n equal to 1. Okay, and then this line produce this. Means the electron move from n equal to 3 to n equal to 1. So this is the electron move from n equal to 4 to n equal to 1. This is the fourth line. The electron move from n equal to 5 to n equal to 1. Okay, we check when across left to right, the delta E decrease, frequency decrease, but lambda increase. So we have to check the highest lambda value is over here. But here is the lowest delta E or lowest E value or frequency value. Let's check one more line spectrum, which is n equal to 2 Balmer series. So here is the first line of Bauman series, which is from when electron move from n equal to 3 to n equal to 2. So the green line is the second line of Bauman series when n equal to 4, electron move from n equal to 4 to n equal to 2. And then the blue line is the third line of Bauman series when electron move from n equal to 5 to n equal to 2. This is the emission series of hydrogen atom from Lyman, Balmer, Paschen bracket until P form, which is n equal to 5. So we can calculate the delta. If we want to check the energy, right? Okay, we ignore the positive negative side. Okay, we just take the magnitude. Okay, so this is a summary. Lyman series, the n final is equal to 1, Balmer n equal to 2, and then Lyman at the region ultraviolet, Balmer at the region of visible, then Paschen bracket P form at the region of infrared. So Lyman series, all the electron fall back to n equal to 1, Balmer n equal to 2 under visible region. Okay, just now Lyman is ultraviolet region, and then Paschen drop to n equal to 3, bracket n equal to 4, and then P form drop to n equal to 5. 3 of these series are under infrared. So that's all for today. Don't forget to follow my IG at ChemiComSL. Subscribe, like and share my YouTube channel ChemiComSL, and follow my Facebook ChemiComShirley. Hope you all learned something. Thank you.